Hello everyone. In this video, we shall discuss the laws of logarithms. And these laws may be used in solving for exponential and logarithm functions which will be discussed in the succeeding videos. So first, let's recall that whenever we have a function f of x, and if we have its inverse function f inverse of x, we know that if we get the composition of these two functions, their compositions will always be equal to x. So for instance, if we have the exponential or the basic exponential function a raised to x, its inverse is f inverse of x, which is the basic logarithmic function. So if we are going to apply f of f inverse of x, this can be written as f of the logarithm of x to the base a. And this logarithm of x to the base a will replace x here in the basic exponential function. So it will be a raised to the logarithm of x to the base a. Now, if we apply the f inverse of f of x, then we shall replace f of x by a raised to x. And in this case, a raised to x will replace the x here in the basic logarithmic function. So which means that this is equal to the logarithm of a raised to x to the base a. So now, given the following compositions, and since the compositions of f and f inverse and the composition of f inverse and f are both equal to x, then this means that both of these expressions are equal to x. So for example, that to apply these properties, let's have the following. So let's evaluate 5 raised to the logarithm of 3 to the base 5. So this means that if we have the exponential base 5 and the logarithmic base is also 5, then this means that this is just equal to 3. Now for the second one, the base is 10 and the base of the logarithm is 10, then this is equal to 2 times 1. For the third one, the exponential base is e, the logarithmic base is also e, so this is equal to z plus 4. And then for the fourth one, the logarithmic base is 7, the exponential base is 7, so this means this is equal to the exponent 4. For the fifth one, the logarithmic base is 10, and then 1000 can be written as 10 raised to 3, so that means the exponential base is also 10. So this expression must be equal to 3. And then for the last one, the logarithmic base is e, the exponential base is also e, so this thing is equal to negative of n. So that's how we apply the previous properties that we have derived so far. Now, so for the additional laws of logarithms, let's have the first rule. Now, whenever we have the logarithm of a product n times n to the base 3, then this can be written as the sum of the logarithms of each of the factors m and n. So for example, let's expand the logarithm of 5x to the base 5. So this can be written as the logarithm of 5 to the base 5 plus the logarithm of x to the base 5. So this is allowed because we have the product of 5 and x. However, the logarithm of 5 to the base 5 can be written as the logarithm of 5 raised to 1 to the base 5. So by the previous properties, this is just equal to 1, and then plus the logarithm of x to the base 5. Now for the second bullet, let's condense this into a single logarithm. Now the constant 3 must be written in terms of logarithm of base 3. So this means that 3 can be written as the logarithm of 3 raised to 3 to the base 3 plus the logarithm of y to the base 3. Now 3 raised to 3 is 27, and since we have plus here, or the sum of two logarithms, then this can be combined as the logarithm of 27y to the base 3. Now, for the second rule, if we have the logarithm of a quotient m over n to the base a, this can be expanded as the difference of the logarithms of the numerator and the denominator to the base a. So for example, let's expand logarithm of z over 16 to the base 4. So since this is a quotient, we can write this as the difference of the logarithms of z and 16, both to the base 4. But 16 can be written as 4 squared, so which means that this logarithm is simply 2. So which means that this is expanded as the logarithm of z to the base 4 minus 2. Or it is negative 2 plus the logarithm of z to the base 4. Now, for the second bullet, let's condense this expression into a single logarithm. So just similar to what we did earlier, we have to write 2 as a logarithm of base 7. So we can write that as logarithm of 7 squared to the base 7, and then minus the logarithm of g to the base 7. So 7 squared is 49. So we write this as the logarithm of 49 over g to the base 7. Now for the third rule, if we have the logarithm of m raised to an exponent c to the base a, then we can bring down the exponent c and multiply it with the logarithm of m to the base a. So for example, if we are supposed to apply this rule number 3 into these expressions, then these are equal to y times the logarithm of x to the base 7. Now for the second one, this 5 here shall be multiplied to 2, so we get 10 times the logarithm of z to the base 2. Now, if the base is 10, or if we are working on the common logarithm and the natural logarithm, the three rules that we have discussed so far will also be valid. So whenever we have the logarithm of n times n, it's equal to logarithm of n plus logarithm of n. Logarithm of m over n is equal to the logarithm of m minus the logarithm of n. Logarithm of n to the c is equal to c times the logarithm of n. And then that's also the same thing whenever the base is 2. Or if you are working on the natural logarithm ln. So let's have additional examples for expanding and condensing logarithms. So for this problem, let's expand the logarithm of 16x squared over y cubed to the base 4. So since this is a quotient, we can write this as the logarithm of 16x squared to the base 4 minus the logarithm of y cubed to the base 4. Now the first logarithm is product of 16 and x squared. So we can write that as the logarithm of 16 to the base 4 plus the logarithm of x squared to the base 4 minus the logarithm of y cubed to the base 4. Now simplifying further, the logarithm of 16 to the base 4 is 2. And then this thing here, we can apply rule number 3. So we can write it as 2 times the logarithm of x to the base 4. And then also this one, we can apply rule number 3 by bringing down the exponent 3. So it's 3 times the logarithm of y to the base 4. So this is the expansion of this particular logarithm. And then for the second one, we have the logarithm of 10 times cube root of x times y to the 4th. So the logarithm here is common because the base is 10. So if we are going to expand this, we will rewrite this first as logarithm of 10 times x raised to 1/3 because cube root of x is x to the 1/3 and then times 1/4. So we can write this as, since all of these are products, so we can write them as logarithm of 10 plus the logarithm of x to the 1/3 plus the logarithm of y to the 4th. Now logarithm of 10 is simplified as 1. And then applying rule number 3 in the succeeding logarithms, we get 1/3 times the logarithm of x plus 4 times the logarithm of y. And then finally, for condensing examples, for this particular expression, this constant 2 must be written as logarithm of base 3. So we can write that as the logarithm of 3 squared to the base 3. So first, we need to combine the first two logarithms. So the first two logarithms can be written as the logarithm of 9 times z to the fourth, because this one is z to the fourth. So 9z to the fourth to the base 3. Minus this 1/2 here can be written as exponent of x. So that's going to be logarithm of x to the 1/2 to the base 3. And these two logarithms can be simplified as the logarithm of 9z to the fourth over the square root of x to the base 3. And then finally, for the last item, so we can write this first as ln of y to the fifth, and then minus ln of z squared, minus ln of x to the fourth, plus ln of e to the sixth. Now we group all those ln's with that are positive, and then we group all those ln's that are negative, and then factoring the negative sign, we get ln of z squared plus ln of x to the fourth. So for the first grouping, combining them, we get ln of y to the fifth times e to the sixth. And then for the second grouping, we combine them as ln of z squared times x to the fourth. And then using law number 2, we get ln of y to the fifth times e to the sixth over z squared times x to the fourth. So this ends our video about laws of logarithms. So I hope that you learned how to use these properties and laws so that you can successfully solve the succeeding problems involving exponential and logarithmic equations. So thank you for listening in this video. So don't forget to subscribe to my channel.